So what we're looking at today is synthetic division. What we're going to be looking at today is synthetic division. Now, synthetic division is going to be similar to long division, actually not quite too much, but it's still going to be dividing polynomials. We'll still be dividing polynomials. And I believe you're going to like synthetic division better than long division. You're going to like synthetic division better than long division. Now, there's a few key steps in how we set up synthetic division. When we set up synthetic division, the first thing we're going to do is we're going to make what I call a cubbyhole. So we'll cut it in a line. This is the first setup in synthetic division. Now we're going to have a number that's going to go in the cubby, and we're going to have a set of numbers that goes here. And that's what we're going to find next. And it's going to make this division a lot easier. Now the number that goes in the cubby is going to come from us solving m minus 3 equals 0. We're going to solve what we're dividing by equal to 0. We're going to see what it equals. M minus 3 equals 0. I want to solve it. Well, to solve this here, we would add 3 to both sides, and we get that m is equal to 3. That goes inside the cubby. Any questions on this here so far? Any questions on any of this so far? Okay, now the next thing we're going to look at is what's being divided, this here. Is this in standard form? Yes, the biggest exponent is 3, so we have m cubed is the biggest one. Then do we have m squared, m, and a number? Do we have anything missing? So that's what's going to go here. Go right here. Now we're not using the variables. We only want the numbers in front of them. So what would be the first number in front of the variables? It'd be? And then? So the numbers without the variables go across the top here. Any questions on any of this here so far? You all about ready to start synthetic division? Our first step in starting synthetic division is I drop the first number down. We good with this so far? Now we multiply 3, the number in the cubby, by the number under the line. So for us, this here would be 3 times 1, which is? You take that multiplication and put it under the next number. So you take that, we do 3 times 1 and get 3. We put that 3 under the next number, so that would be negative 13. Add straight down. What is negative 13 plus 3? Negative 10, okay. That goes right here. Anybody have a guess at what we're going to do next? 3 times negative 10, yes. And 3 times negative 10 is? Okay, what do I do with the negative 30? I'm going to put it under the 24. And then we add. We add those two together. 24 plus negative 30. Any questions on this so far? Any questions on anything we've done so far? What do we do next? 3 times negative 6. Which would be negative And then we would add, which would give us 0. Any questions on anything we've done so far? We have one last step that we're going to do. And the first thing I do after I finish with synthetic division is I box the last number. I put a box around the last number under the line. Since I don't have any more numbers here, we're done. Because 18, once we hit the last number in that row, we're done. Yeah, so since if there had been a number up here, then we would have kept going. But since 18 was our constant number in our equation up here, and we already finished that, we're done. So we don't have to add anything on. Any other questions? Okay, now probably you're wondering why we box this. This is our remainder. This is the remainder. So for this problem here, it has a remainder of 0. It doesn't have one. And that's fine. But it gives me an idea. This is the remainder. Well, we still need the variables, yes? Because this doesn't have them anymore. We need to put them back in. We took them out. We've got to put them back in. Now, the 0 is the remainder. The number next to it is going to be our constant number, the number without the variable. The one after that would be n, and the one after that would be what? If you ought to take a guess. M squared. Really, we're saying 6. The negative 6 has m to the 0. Well, anything to the 0 power is just 1. So I box the remainder. The number after it, in front of it, doesn't have a variable. The number in front of it is m squared, m cubed. We would just add 1 to it. So the final answer for this here is m squared minus 10m minus 6. And that's it. Questions on this here? It'd be similar to what we did yesterday. So I'll erase this here. So it'd be m squared minus 10m minus 6 plus our remainder over. So what did we divide by? So the remainder, we'll treat it the exact same way we did yesterday. It's just here we have to put it back in. Questions on this here? Do we like this better than long division? Let's look at this one here. All right. I'm going to start off by drawing my cubby hole and the line. So let's find out what goes inside the cubby hole first. So we would do what? V plus 4 equals 0. To solve this for V, we would subtract 4 from both sides, giving us that V is equal to what? Negative 4. So negative 4 goes inside the cubby. Now let's see what goes across the top. So what would be our first number? And then? And then? And then? And then? And lastly? So why did I have 2 zeros? Yes. Because v to the third and v to the second are not there, we have to add them in with zeros. Just like we did with long division. With long division, we wrote it in as plus 0v cubed plus 0v squared. Here we can just put 2 zeros for those spots. Any questions on this here? What's our first step? Next step. We need to bring down the 8. Then what do we do? Yep, we're going to going to do negative 4 times 8. Well, negative 4 times 8 would be negative. Then what do? We negative 32, or 32 plus negative 32 is? What is negative 4 times 0? 0. 0 plus 0. Negative 4 times 0. Add. Well, negative 4 times 0 again is going to give me 0, yes? 5 plus 0 is? Okay, now we're going to do our multiplication again. And have negative 4 times 5, which is? And negative 20 plus 20 is? 0. What do we do next? Box the remainder. Box the last number. Again, I boxed the remainder to remind myself that it is the remainder. Because this number here is the remainder. This is our term without a variable. Then we would have v to the first, v squared, v cubed, and v to the fourth. Because we have our remainder, our number without a variable, v squared, v cubed. So what would our answer be? 8 v to the fourth plus this v cubed, v squared, and v. Those are all just going to be what? 0. I don't have to include them. If they're 0, they're just not there. We don't have to write them out. So the only numbers that we actually have are 8v to the 4 and 5. If there's not a sign written there, it is understood to be positive. If there's not a sign in front of the variable, it's understood to be positive. Questions on this here? On the test, I would make sure to rewrite out what your answer is. Just don't leave it like that. Don't leave it just in there. Rewrite it out. Any questions on these here? Let's look at this one here. This one here has a slight problem. And it's coming with the fact that x, what we're dividing by, is a 3x. I can't have it as a 3x. Well, that's easy, right? I can divide it by 3 and I just have x, yes? So that means I'm dividing by x minus 1/3. Yes? I can't just divide that one side by 3. I have to divide every single thing by 3. I have to divide it all by 3. Well, 3x cubed divided by 3 would just be x cubed. Well, 4 does not divide by 3. 17 does not divide by 3. But 6 would do 2. If I remember correctly, there's not going to be one of these on your homework assignments. They don't bring these up. Just kind of like with long division, they don't bring up the fact that the first term doesn't go into a number evenly. Like they don't bring up this example here. Because what times 2 would give me 5? Or 5x squared? Be 5/2 x. We don't talk about these in this class. We don't talk about how this works out. We're not worried about that. But here, if there's a number in front of this x, we've got to divide it by 3 to make it 1. So this does work. Now everything else stays the same, and this one here actually works out pretty nice. Well, I need to solve for the value of x. So this here we would add 1/3 to both sides and get x is equal to 1/3. So before we start into this, are there any questions on this here? Now the numbers that go across the top are going to again come from this here. So we would have 1, and then -4/3, and then -17/3 and 2. Okay. Then what would we do next? We would drop the 1. And now we would multiply. So what is 1/3 times 1? 1/3, yes? I have a feeling some of you don't believe me that this is not going to be that bad. We have 1/3 and 4/3, yes? What is -4/3 plus 1/3? -1. Because -4 plus 1 would be -3, and -3 over 3 works out to be -1. Okay. Now we're going to do 1/3 times -1. -1/3, and we put that under the -17/3. And then we have to add. Well, -17 plus -1 would be -18, yes? What's -18 over 3? -6. Okay, lastly, well, 1/3 times -6 is we can add these together, and if we add them together, we get, since the last number, box it. So even though we had some fractions, this came out to be all right, yes? Didn't come out to be too bad. Now we just need to put the x's back in. Well, this is our remainder. Would 6 have an x? Would -6 have a variable? No. The 1 would be, so our answer would be x squared minus x minus 6. And it's worked out that all the ones we've done so far do not have a remainder. They have a remainder of 0. It doesn't always work that way. I mean, we can have a remainder, because the ones we worked yesterday had a remainder, yes? So can these. It also could work out the other way around, that long division will have a remainder of 0, and that's fine. Questions on these here? Any questions on anything we've done so far? How do we feel about these? Do we need to see another example of long division? I mean synthetic division, not long division. We feel comfortable with these here? Yes? If we feel comfortable with these here, I'll go on and move on to the next thing. Which is this here. Because if y'all feel comfortable with these here, we'll move on. If you feel comfortable doing synthetic division, we'll move on to this here. Now, there is something interesting with long division and synthetic division. So, evaluate a polynomial. Now, if I told you to evaluate this beforehand, before using the synthetic division or going over that, what would we do with the -4? Well, I would just what? Plug it in for the value of x, yes? So that'd be 5 times -4 to the third minus -4 squared plus 13 times -4 plus 29. And we can type this into a calculator, yes? So if you have a calculator, go on and type that in and see what you get. Don't say it out loud whenever you do get it, because let's do synthetic division. Let's do synthetic division. Well, we've been doing most of this class period. Well, one nice thing is they told me x is equal to -4, yes? I don't have to solve anything. I just put -4 into the cubbyhole because it told me x is -4, yes? So it told me that value. I don't have to do anything with it. Now, the numbers in front of the variables that go across here would be 5, -1, 13, and 29, yes? What would we do first? I would drop the 5. And then what would we do next? -4 times 5, which would be -20. And then what would we do? We would add -1 plus -20 would be -21, yes? So we did -4 times 5, which gives -20. We added, now we're going to do -4 times -21, which would be positive 84, yes? Add these. I did positive 97, yes? Then we'd multiply again, -4 times 97. Well, that'd be 8, carry the 2, -388. And if we add these together, well, it's going to be -3, because this would be 9, 8, carry the 1, -359. So I know at least 2 of y'all plugged this into the calculator. You evaluated it for -4, yes? What was the value that you got when evaluating it? What did we get as a remainder? -359, yes? It works out the remainder, when you get, whatever the remainder is, would be the same as if you plug that value in for x. So evaluating it, plugging it in for x, and the remainder using synthetic division and actually long division will be the exact same every single time. So that means I can use synthetic division or long division to find out what the value would be at that point. And this here is going to be very useful, very helpful later on. But since we know that I can store this into the calculator and do multiple values, it's a little bit easier to do it this way. Is if I had to type multiple numbers in, this here might take a little bit longer than using synthetic division. Any questions on this here? Okay, well, let's do at least one more of these. So if I want to evaluate this for when x is equal to 5 using synthetic division, I'd set it up. Now, what number is going to go in our cubbyhole? 5. I don't have to solve it for anything because it told me x is equal to 5, yes? If it has x equals, that's just the value. Now going across the top, we'll have 4, negative 10, and negative 21. Then what do? We drop the 4. 5 times 4 would give us 20, and we put it under the 10. Actually, nope. Then what do we do next? Add, and we get 10. Because 20 minus 10 or negative 10 plus 20, the 20 is bigger. 5 times 10 would be 50. Add these together, and we would get 29. So f of 5 is 29. So if I plug 5 into the function, I would get 29. Questions on this here? Any questions of anything we did today? Yes.
You're only looking for the remainder?
Yes. Because the remainder actually is going to be the same value as if we plug that value in for x. So if I did 4, let me get a different color. Okay, let's go this here. So if I did 4 times 5 squared minus 10 times 5 minus 21. If I did this in the calculator, well, 5 squared is 25. Negative 10 times 5 is negative 50 minus 21. Well, 4 times 25 is 100. I can combine these two here to give me negative 71. Well, 100 minus 71 is 29. It works out that when we evaluate it for a given value, it's going to be the same as the remainder. Questions on these here? Do we feel comfortable with these here? Yes? Now, you probably noticed I did skip this one here, yes? Well, it'd be nice if these worked out too, don't they? Wouldn't it, with synthetic division? They do. We can actually do this with synthetic division. Now, don't copy any of this down. Because what goes in the cubbyhole would be 1 and 4. We would actually solve it for x squared. And across the top would be 2, 1, negative 15, negative 2, 10, and 24. So this is just like we had, except for now I have 2 numbers inside the box instead of 1. Yes, negative 24, thank you. Instead of just 1, correct? We would actually have 2 lines. This would drop all the way down here. This would come here. And we end up doing 1 times 2 here. 4 times 2, or well, 4 times 1, which would give us 4. Then we would add down to get 3. And negative 11. Then 1 times 3. 4 times negative 11. Y'all can already see here there's a lot going on, yes? I do not teach this in this way. It's not normally taught in pretty much in most any kind of high school level because of the fact that it is so much going on. It does work. We can use synthetic division for it, but I would not use synthetic division to solve this. You're better off sticking to long division. Is there anything wrong with doing it by synthetic division? No. But there's just a lot to keep up with. There's a lot to keep track of. So if what we're dividing by has a power greater than 1, so it's a quadratic or higher, I would stick with long division because it's going to work easier than synthetic. doesn't work easier than synthetic division.